Oh, hello and welcome to all. My name is John Favaro of Trust IT and AI Sprint, and I will be moderating this webinar today. So we have the luxury today of being able to do a deep dive into a very pleasant topic, winemaking. We're going to look at a single use case of the AI Sprint project, and this use case is concentrating on revolutionizing vineyard maintenance through artificial intelligence. So first we'll have an introduction, as you can see, to AI Sprint, where Danilo Ardagna, the coordinator, will not only introduce the project, but also set the context in which our Farming 4.0 use case is positioned to help us understand the big picture. Then we'll hear from our two protagonists, Enrico Abate-Daga, who will give us the full technical details of the use case, and Christophe, who will be speaking from the point of view of the user, literally working in the trenches of viticulture. Then we'll have a panel session with our speakers and also two more protagonists. Davide Facchinetti of the University of Milan, and who is involved in research in AI in agriculture, and Gustavo Lardone, the founder of Italian Good Mood, whose mission is to promote natural, green, and sustainable food production, another emphasis of this use case. So a quick word about who's online today with us. As you can see, the largest segment of our audience today is AI application developers. So I expect to get a lot of interesting questions. And speaking of which, a couple of words about housekeeping. As I said, there will be a panel session at the end, but you are most welcome to write questions and comments at any time. And do it in the QA box that you should be seeing at the bottom of your screen, or just do it in the chat if you can't find it. And today, the best question gets a bottle of wine. Well, maybe. So now we'll start with Danilo, who will present us to the AI Sprint project. And now, Danilo, the floor is yours.
Okay. Okay. You see my screen, right?
Yes.
Okay, great. So welcome everyone, also from my side. I'm the coordinator of the project and I'm associate professor at Politecnico di Milano. So our project, AI Sprint, has general goal to support the design and runtime management of AI applications on computing continua. So nowadays, almost every day AI is on the news. If we look at the market data, we see that there is really a steadily growth on AI on one side, and also on the other side from the edge devices and IoT devices that actually today they are becoming more and more powerful and can support also some the executional part at least of the AI-based components application. So is also, I mean, moving towards the edge of the network. AI, I mean, can enhance, because on one side we reduce the latency to reach the cloud side backend, and on the other side we can also work under disconnectivity. And that's especially in our use case that we'll see today is a very important aspect. And so there is really a common consensus that the most innovative applications will come from the execution of AI at the edge of the network. But on the other side, this also opens a lot of challenges because of the heterogeneous nature of edge resources. So if we look at the design flow of an AI application, that's a really complex workflow, because AI is hungry both from the engineering perspective, both from the cloud perspective and the silicon, so of the power, the computational power of the servers on the cloud side, but also of the devices that are involved in on the execution on the field. So developing AI application usually is complex, also because nowadays there is a lack of expertise. There are a lot of frameworks, and usually the AI designer want to really jump on the very last and new framework. AI application design is a trial and error process. So, and usually the expertise that you gain by designing an AI application, for example, for image processing, this expertise is difficult to be transferred, to be moved to the design, for example, of natural language processing application. To be accurate, AI models also need very large data volumes, and whenever we consider data coming sometimes from end users, we also have some privacy and security concern. Whenever we consider the model is trained and we move to production, then we also have a set of challenges because, again, we have to cope with the heterogeneity of devices. We have to scale whenever it's possible the resources of our applications in case of workload fluctuations. And in general, we would like to have an efficient use of resources, both from the cost perspective, because we still rely on part of the execution on the cloud side, but also on energy, for example, because on the field, most of the time we have also some energy concern. We would like that the battery of our devices lasts at most. And finally, as a very last point, if you look at an AI application as a whole, actually the machine learning code is a little piece of our application. Actually, only about 10–15% of the code of the machine learning code is a part of a general framework and a general infrastructure where we want to automate the configuration of the underlying resources. And actually, AI Sprint is funded on the cloud course. We are not a pure AI project, but we are funded from the cloud division of the European Commission. And finally, the very last point is, if you look at the data, still today, most of the machine learning projects fail. And one of the most important reasons is, on one side, the cost of the application, because usually the AI application development is exploratory. And on the other side, also because of the quality we mean the quality of the AI models, the final accuracy of the AI models, but also the quality and the performance that you obtain while running the application. So which are the goals of AI Sprint? AI Sprint wants to develop an integrated design and runtime framework where we provide some simplified programming models, and we would like to our developer just to focus on the code and to add constraints on the execution time, for example, of the application, and on the resources by just providing annotation on the code. These applications then can be automatically deployed to production, and according to the changes in the environment, these applications are also automatically reconfigured. We are developing some security tool that allow actually to run AI application also in environment where the opponent have root access to the underlying resources. And finally, in any case, we are building some vertical building blocks which are specialized for AI application development. So we have solutions for privacy preservation, distributed training, and network architecture search. All our tools, the most of our tools are really open source. This is in a single picture, the tool chain that we are developing. We based our solution on OpenStack for provisioning the virtual machine and the underlying resources, and we rely on Kubernetes for orchestrating Docker containers. All our applications are based on Docker containers. Then on top of these standard, let's say, industry standard building blocks, we build our solution, which includes Scone, which is our solution for confidential computing. We have developed a monitoring infrastructure that is able to gather performance metric, application metrics across the full stack, down from the hardware up to the application level. We support our inference pipeline runs according to a serverless computing paradigm, and so we base our solution on Oscar, and we have developed a tool which name is Oscar P that automates the performance profiling of Oscar application in a way that we can automatically train machine learning performance models in a way that we can predict the performance of our application under unseen configurations. The orchestration of resources is obtained through the infrastructure manager, which follow an infrastructure as code approach and is compliant with the Tosca standard and automates a multi-cloud provider deployment of the virtual machine in public clouds. We can also flow the execution of some components to AWS Lambda, and for this we base our solution on SCARD, which is integrated with Oscar. Then, given the effort that we know that AI applications are really computing intensive, and they can gather important benefit up to a 40 times speed up when running on GPUs. So we are developing also some specific solution for supporting GPUs, and in particular, Arcuda allow us to access remote GPUs. And we are also building a scheduler, a GPU scheduler that supports the training of an AI application. And this scheduler is able to reduce, to minimize the energy of the cluster consumed by a cluster in a private setting and the execution cost in a public cloud setting. We also consider energy as an important metric, and we have Krake that allow the live migration of application from one site to another if the second site, for example, has better green energy sources. In case performance are important, we also rely on COMPS, which is developed by a Barcelona Supercomputing Center. And COMPS actually allows to, just by annotations, to transform sequential code into parallel code. We support the design time exploration to identify, for example, which is the best VM flavor to support the execution of an AI application component, given some deadlines that we would like to fulfill a priori. And then that's for the design time. And then we have a space for AR, which is the runtime counterpart, which is able to react to workload changes. We support also the network architecture search, and in particular, we can trade off the accuracy of the final AI model with the performance, so the computation time that this AI model requires. And in case, since we know that edge computing can really benefit today by 5G network, we have also one component, CIMA, which has been developed here at Politecnico, that simplify and support and optimizes the deployment of network functions. Finally, for what concerns the design of application, we have defined our design framework where we support the developer just by requiring them to annotate their code. And finally, from this component, high-level component, we can automate the creation of the Docker images through Toscarizer, which is a new tool that we have developed during the project. We are validating our tools through 3 use cases. The first one is personalized healthcare, which involves Barcelona Supercomputing Center. So here we are developing an application for atrial fibrillation detection, and for the general goal is to support patients which have a risk of strokes. We are building also a maintenance application where drones go to wind farms and take pictures to try to identify defects on the wing, for example. And finally, which is the core of today's webinar, we are also developing a farming 4.0 use case where really we would like to minimize the use of pesticide on the field. This is a really challenging and interesting use case for us because we have several layers. So we have tractors that goes on the field and spray on the leaves of grape. Then we have part of the computation actually happens also at the farm itself, where we might have a laptop, where we might have servers there. And then there is part of the computation that also happen on the cloud side. So here, the core characteristic of our solution that are really relevant for the use case are on one side, on the field. What is really important is to provide performance guarantee, because given the image that is taken, we need to process this image within a strict deadline in a way that we can modulate the sprayer for the spraying of the pesticide. And then the other important characteristic is that Gregoire and actually Skaylink, they are the one involved in these development activities. They have multiple customers, and they would like to leave the choice of the cloud provider by their end customer. So the fact that our infrastructure manager is cloud agnostic and allow us to redeploy the resources to any cloud provider is really, really relevant. We are now almost to the end of the project, of this journey. We are gonna finish at the end of December. And now we're really at the stage of validating our tools. So we're performing some internal validation, but we're also trying to engage also external user that would like to access our tool and to test our solution. Actually, we have a cloud provider, a European cloud provider in our consortium. So you can even also use cloud resources for free because they are provided by internal provider. This is the consortium. We are involving 4 research institutions that we are reported in the first row. We have also 4 SMEs. That's really a teamwork. I'm really happy that we are going to really successfully deliver our toolchain, the toolchain that we promised almost 3 years ago. So I'm really taking this opportunity to thank all the consortium, because really it was hard to reach this stage, but now we are seeing some very nice results. So that's all from my side. Enrico, the floor is yours. Okay, you can go with the technical details.
So, okay, thank you, Danilo. Let me share my presentation. So I think you see it. So my name is Enrico Abate-Daga from Skaylink, and I will present the use case from a more technical point of view. Skaylink is an IT company, and in this use case, we were responsible for the IT part of the project, so the software and the assembling of the sensors, whereas Gregoire provided the tractors, the sprayers, the vineyard, and the wine, which is also very important. So I will first briefly explain you what we want to do in the use case, and then I will show you some details about the technical implementation. So first of all, our goal is to optimize the treatment in vineyards. So treatment with pesticides is really important, but it has to be limited because it has a negative impact on the environment and also on the consumers. Now, if you look at today's solution, farmers are able to tune the amount of pesticides to be used at lot level using a map of the vineyard. And the tractor will then read the map, use GPS to tune the amount of pesticides accordingly. Our goal is to use sensors that we put in front of the tractor to tune the amount of pesticides at plant level based on the volume of the foliage and on the shape of the canopy. Our goal was or is to reduce the usage of pesticides by at least 30%, which would have a huge positive impact on the environment. Just a brief overview of the project procedure. We started by building the smart farming device, or the box as we call it. Then we use our box in the field to collect images of the vineyard. We use the images to develop a module for the volume estimation and the canopy shape identification. We then assembled everything and kind of wired it together with the canvas of the tractor. And in July, August, we had a final test in the vineyard. In parallel, we develop an advanced farming management application, which uses the image collected by the tractors on the edge and processes them to estimate the yield of the crop and also to identify possible diseases. The first part of the application runs on the edge, so on the tractor. The second part of the application runs on the farm or in the cloud. Very quickly, the components we had on the tractor. So we had a depth camera and an RGBD camera and a high-quality GPS. Everything was wired together on a computer. And of course, farmers cannot use a keyboard and a monitor on a tractor, so we use a very simple display, which allows farmers to start, stop, and transfer data from the box. So last year, here you see the box and the sensors, and here you see the tractor collecting images. After this round of collection, we analyzed all the images and we also made some calculations. So first of all, we decided to use the depth map to estimate the foliage volume, keeping in mind that the tractors moves at about 10 kilometers per hour, and keeping in mind that the camera is in front of the tractor, the sprayer is behind the tractor, and the tractors are really large. We estimated that we need 3 frames per second, and that we would have a bit more than a second to calculate the foliage volume. We developed 2 different models. So the first one is the one you see here. This is for the more advanced sprayers, which can modulate and tune very quickly the amount of sprayers. For those sprayers, we provide a number between, let's say, 10%, 20%, up to 100% of amount of spraying. And we provide 5 rows of data so that you can spray the middle part of the plant more than the top or the bottom. Not all our sprayers are so advanced. Some sprayers are either on or off. So we modified the model to provide a 0%, 100% signal. And we wired the box to the canvas isobus of the tractor. And then we, as I mentioned before, in July, August, we did our final field test. So the most important points for us were, first of all, to make sure that the box and the tractor can really communicate and it works. It's very difficult to test in a lab with a tractor because it's kind of large. We don't have one. So the wiring worked very well. Then we wanted to make sure that the images and the spraying process were synchronized, which meant the images processing was performant enough, the latency was very low, and we were able to send the image to the isobus at the right time. There was one very important challenge that we identified very early in the project. And it has to do with the uses of the Oscar module, which provides function as a service. Now, looking at from an IT point of view, function as a service brings huge benefits. It provides a layer of abstraction between the developer and everything which is infrastructure hardware. So really simplifies our job. But any function as a service module brings some latency because it relies on a Kubernetes cluster, which needs some time to spin off. So we were afraid that we would not be able to complete on time. It turns out that Oscar was really fast, and the colleagues in Valencia really did a great job. So the average inference, so here we only have 5 cases, but was always below 1 second. So usually below 0.8 seconds. So we were always able to process the image on time. So it was a great factor. And the field test was very successful. We collected the images, and then we analyzed them in the lab just to make sure that we really spray at the right moment. Danilo already presented this slide. So I just very quickly, we have some edge component, and we have some farm and some cloud components. And from our point of view, the really greatest advantages of AI Sprint were, first of all, that we could abstract from the underlying infrastructure. So our developers didn't really care so much about the box hardware. They really focused on the software component. The second advantage is that we can move at runtime modules from the cloud to the farm back and forth as needed. And the third advantage, which was really the main one, was that our solution is cloud provider agnostic. So we don't have to convince our customer that provider A is better than provider B. We can serve any provider they need. Finally, just to look at the main advantages, again, from a technical point of view. As I said, the application developers were able to speed up the process by describing the application rather than coding and wiring in software all the components. Oscar really offered a huge abstraction layer, so it greatly simplifies our work. The management and the deployment of the devices is also simple because we can use tools that really push changes and move components back and forth for us. And in general, the architecture is provider agnostic. And this is a point that I repeated many times, but it's really important for our customers. They are afraid of a lock-in with AWS, Google, Azure. So offering the possibility to use cloud providers without being locked to them is a great commercial benefit. So thanks a lot. And Christophe, then you can now explain us the project from a point of view of the business.
Yes, thank you, Enrico. So as you say, I will present you the project Sprint from the side of the end user and the material provider. So I share my screen. Okay. So my name is Christophe Baron. I'm working in Gregoire company. During this presentation, I will present you the company, Gregoire. Secondly, I will describe you some important points for the user. Firstly, I will give you some information and specificity linked to the wine growing, who have some point quite particular. Then I will talk to you about the commercial aspect of this project and what can be the interesting point for Gregoire. Finally, I will highlight some benefits and important points I saw in AI Sprint project linked to the using of the tools we have developed. So Gregoire is a company localized in France, in Cognac, in the west of France, in the middle of Cognac vineyard. Our market is around fruits, and especially harvesting, and also protection of those fruit and of those crops. We are focused on mainly on grape, but also we are proposed solution and tools for olives, almonds, and pistachios. And we sold our product all around the world. Everywhere you can see this kind of production, we have material to harvest or spray and treat and protect those culture. So our materials were harvesters. In this case, it's grape harvesters, but also olives harvesters. And then to allow farmers to manage all the works during all the season, we propose we sell also tool holders like this one, was designed for Spain, for Champagne market, and for other markets. We also proposed material, specifically sprayer, to protect the field. What the user expecting behind this project? First of all, the surroundings of the projects was agroecology, and all the changing of way of managing the field, managing the crops, managing the culture to reduce using of products, doing more with by working less, and also protect the culture, protect the surrounding, the ecosystem, and also protect the environment. Sorry. So one important fact is to reduce using of phytosanitary products. It means that we have to use those products, but use at the right place, at the right time, and at the right quantity. And it's totally linked with the crops monitoring. It means that managing the field year after year can allow us to find solutions, to work differently, and to focus on some area of the field and not managing all the field in the same way and at the same time also. And another important way aspect of the project is how to manage the climate pressure. It means a lot of water pressure, temperature pressure, and also events like snow or big orange storm who can affect the stability and the perennity of the vine grow of the farmer structure. Some specificity of the vine growing way of working. First of all, you have to consider that vineyard is a 3D culture. It means that we are on the soil, but the vine, the vineyard is also managed with the height of the grapes and the height of the leaf. Well, sometimes some treatment are important for the leaf, some other treatment are important for the grape, and other treatments are important for the wood. So we have to manage and to consider these 3 dimensions, those three dimensions. We also work with limited space because material can run over the field, but also inside the field behind 2 rows. And in some vineyard, you can have less than 1 meter behind 2 rows. And finally, and it's an important thing, vineyards are mainly localized in hilly area, but also in field where there is a really, really bad covering of the connectivity. So by this aspect, we have to find solution we can allow Gregoire to propose some products enough efficient to manage those aspects. And it means that for Gregoire, important point is to expect to develop a range of products like smart sprayer linked to those developments. And we can expect that mainly in less than 5 years, 25% of our range can be smart sprayer. We have also to imagine that our equipments, our grape harvesters, our tall holders can propose more and more functionalities. Actually, we can change the tools, but in the future, we can imagine that we can also change the sensor because those materials are going through the field a lot of time during the seasons. And in one time, we can imagine that we have sensors to count the grapes or to test the wood. And some other time, we have sensors to inspect the leaf. But we can also imagine to have sensors who have multi-using aspects. And the camera we have started to test during iSprints project can be really interesting because those cameras can help us to drive the machine, can help us to estimate the volume of the foliage, can also allow us to count the grape and also to check disease in the field. That's what is really interesting for us. And then we can imagine to develop new tools and new services for vine monitoring and supervision. Those new tools are already interesting because since the beginning of the projects, we have been in touch with insurance company and some other company who are working the protection of the field in a financial way. And they can imagine to use those kind of tools. For example, before and after climate events, we can have an estimation of the yield before an event and an estimation of the yield after an event, and we can also then evaluate the right quantity of grapes we have loose, and we can imagine to pay back the vine grower in a correct way. That's why iSprint have really interested us from this aspect. And one important point, it was, for example, the speed of the computing, because as Enrico says, the 3 levels of the computing in the edge, in the farm, and in the cloud are really important, especially when we treat a field. We have to scan and treat few seconds after the place scan. We are also we can also imagine to after time to develop some other tool to manage the maintenance of the material and some other way. That's more important point I want to highlight. Thank you. John, it's up to you.
Thank you very much, Christophe, for a fascinating introduction to the issues of using AI and this kind of technology in vineyard management. So now we will pass over to the panel discussion. And as I said, we are going to, I would like to ask our panelists to turn on their videos so that we can all see each other. And so I'd like to welcome also Gustavo and Davide to the discussion that we're going to have now. And I see that Danilo is also still with us. That is also very good. Okay, there's really quite a bit to talk about. I would like to start by asking directly. I'd like to put Davide on the spot now. So you are also researching in AI in agriculture. So and you know the academic perspective often focuses on research and innovation. So how do you envision the collaboration between academia and industry evolving in the context of AI-driven agriculture in general? I mean, we've seen some of the research areas that are being addressed right now. Do you see further research areas or in general challenges that are going to need further exploration?
And there is lots of research that are involved in the use of artificial intelligence in agriculture. Especially, I'm working on a similar project that will use a robot to make a treatment in vineyard. Also to exclude the presence of the operator when the treatment is done. So it's important also for not only for the environment, but also for the operator that can be preserved. Otherwise, I think this project is very important because in the major part of the occasion when you are doing a treatment in vineyard, the major part of the spraying are lost in the environment. It is not put directly on the vegetation. And there is in some cases the opportunity to use some special machine, special coverage with that allow you to reduce till to 98% the drift, but they cannot be used in every condition. So the use of artificial intelligence and the opportunity to modulate the spraying can allow you to reduce drastically the drift and to save money and to preserve the environment. So this is a really interesting result.
Understood. Christophe, I saw you nodding your head as Davide was speaking, and Enrico, I also saw you open up your microphone briefly. So you have comments on what Davide was saying. Enrico, by all means.
Yeah, I can only agree with Davide. I think that I mean there are a lot of opportunities because we can create, let's say, autonomous machines that react to whatever they see without any interference or with little work from humans. Also, what Davide said, there are a lot of challenges. So the fields are not pretty, so the machines would behave always in a very different way. So it's not an easy task, but I also agree with Davide. There are a lot of opportunities.
Yeah, Christophe, I particularly I saw you nodding when Davide said it was not only good for the environment, but good for the operator.
Yes, I think that it's really, really, and thank you to focus on that. It's, I think, the main important point. And we can imagine in a few years to have auto-drive material, robots, but also drone who can start to spray, but the challenge is to reduce the product to apply on the vineyard That means that to decrease the volume, we have to spray at the right place, at the right quantity, and at the right time. That's why our projects are going in this way and are really, really important.
Mm-hmm. Yeah. And you also talked about the idea of sensors being multi-use and being able to use in many more ways, which is related to the idea of using drones and things like that. Can you expand on what you mean by that? Like, what are the applications that can?
Actually, on our machines, we use cameras only for control the positioning of the machine in the field. But during this project, during these 3 years of project, we have seen that that those cameras can also maybe be used because the machine running 1 time, 2 times, 3 times in the field, and we can capture other information. It was the idea of multi-using of one tool, of one sensor for multi-solution, multi-using, and it's important also to have the chronology of the evolution of the field, and yearly we can increase the knowledge of the way of growing in each part of the field. And it's also an important point to reduce using of pesticide and to adapt treatment and other products to help the quality of the growing by decreasing the using of those kind of products, but to apply the right work at the right place.
So you see actually a broader application of the whole concept of what's being done here overall. We do have a question for you now from the audience, for you, Christophe. What do you plan to do next? This is from Giuliano Langella. How to become a user of the solution you implemented for precision farming. This is for everybody, also for Enrico, for the whole project. And he's also interested in possible collaboration within ongoing projects that are involved. What can we do for Giuliano? Danilo, if you're on.
Yeah, there is during this project, it highlights a question for the company. Are we are we tool provider, or are we
good point. Are you an end user? Yes,
it's a strategical question for the company, and actually it's hard to have a clear decision. It's sure that our product have to allow to those modulation to allow to capture a signal and send a signal somewhere, and maybe we can become time after time provider of computing solution. Maybe it's like, for example, Xerox. At the beginning, they were tools provider, and now they were solution provider. But it's a strategical question for the company. But it shows that our tools became more and more smart. So it's sure. And I think actually we have moved our products to be more and more thin in the way of applicating the products. And the second step is to compute a solution to be a bit more thin also.
Understood. Yes. Okay. Well, let's address another topic that is that was very important. This is, in general, sustainability and environmental impact. And I'd like to ask an opinion of Gustavo, who's involved very much in this. So they're obviously very important in modern agriculture. So how do you see this farming 4.0 use case, or in general, what's being done here, contributing to biodiversity preservation and eco-friendly practices in the production of food in general?
Thank you, John, for inviting me into this discussion. I do believe that in this project, which is a very high-profile technology, and through the work that Christophe is implementing is transforming the innovation into something that is possible to be understood by the farmer, by the user, which is one of the most important stakeholders in this project, right? The second very important stakeholder is the final consumer. More and more sustainability, it is an important variable where final consumers are taking decisions. And the 2030 agenda and the 17 Sustainable Development Goals are at the core of the United Nations. And this technology, by implementing in the smart application and a lower application of phytopharmaceuticals are important. First, for the first stakeholder, which is the farmer, in saving money, which is important for dedicating that money for new investments in technology. On the other side, the final consumers, as I was saying, are becoming more and more aware about the sustainable practices and the quality that is coming out from the health of the plant and the health also of the final consumers. So all in all, I believe that this technology is important for addressing a main concern of final consumers, which are much more taken into consideration in their purchasing decision all the players that are playing on the sustainability environment and the sustainability approach and mentality, right?
Yeah, Christophe, once again, I saw you smiling when you talked about saving money, because you, in fact, did emphasize a lot the commercial aspect. Can you expand on that?
It's clear that the most important point is the saving money for the producer and also for the vine grower. And I want also to highlight an important point. It's also how to train the vine grower on those kind of solution. It means that school, university have to integrate it also those tools to teach future vine grower, future farmer to manage those tools. And I think that the three research, producer, and school have to going through and to allow vine grower to be able to use existing tool.
Davide, would you like to comment on that? Yeah, we thought about you at the same time.
In my opinion, the money saving is not the most important objective that can be reached, because the investment that you have to do for increasing the technology level to reach this result is very high and can be paid only in a long time. But there is another result that you can obtain immediately. Is the decreasing of the residue of the pesticide on the grape. And this is very important, especially for the customer.
Yeah. Well received, indeed.
Is a big point also in terms of quality. If you want to sell your grape.
Yeah, Gustavo, you seen.
Yeah, I want to build on Davide's remark that the initial investment is very heavy. And into that, I believe that the governments, especially European Union, is very focused in supporting this kind of evolution, especially in Europe, because of what I said before, the Sustainable Development Goals. So making the right lawyers and the right people involved in the European Union about these developments that are helping in sustainability is key. And here communication is very important to translate, let me say between question marks, translate the technology that very well has been explained by Danilo and Enrico, but to downloaded to a normal listener who are taking decisions where the investments from the European Union are going.
Yeah, well, that's a very important point, of course. Yeah, let's go right back to Davide then.
There is another important point to remember. In 7 years, 230, the European Union told us that you have to decrease from 50% the use of pesticides. And this use of artificial intelligence and high technology level can allow you to decrease the quantitative that you use by maintaining the same results.
So, Gustavo and Davide and all of you, what would you like to see done in terms of policy recommendations then? What can we tell our policy makers in order to further these goals? What aren't they doing yet that really should be implemented?
If I may, what here I believe has to happen is a common ground of dialogue. Because on one side, there is a very high level technology development. On the European side, there is a very high laws development. And sometimes these two entities are not talking to each other, but the common goal are the same. The common goal are the sustainability and reaching the 2030 goals, as Davide has said before. So I believe this group of a sprint is a touchable solution of putting together all the players in the field with different skills to stretch this information to the right lawyers who are determining where the investments of the European Union are going.
Mm-hmm. Yes, I see. Davide, any comment on that?
No, the only comment is that I'm totally agree with Gustavo.
Okay. Now, well, given that we'd like to make these kinds of recommendations, I would like to go back to Enrico and Christophe, who did the implementation of this. Is it really that generalizable to all kinds of agriculture, this? I mean, certainly this is going to be how easy is it to generalize what has been done so that we can put this kind of technology in the hands of all forms of agriculture? I'm sure you talked about quite a few challenges that you had to face. What is your impression about this?
So I think the underlying technology can be generalized and used in other parts of agriculture. I think there are very specific aspects in every crop. So we did some project with sugar beet, and sugar beet is not the same as grape, and I can imagine that also other form of crops are very different. So there are very specific challenges, but I think the underlying machinery is reusable.
Mm-hmm. Yeah, Christophe, do you share that feeling, even though you've had a specific experience?
Yes, like Enrico says, iSprint is not a project linked to the vine growing. It's only an illustration of we have a problem in field, how we can manage an automatization in the field, in the farm, or in the cloud. And iSprint is providing the solution, not the solution, but the system who can design the solution. And it can be really interesting to apply iSprint in other thematics in the field. Maybe to work on the soil, maybe there is many thematics in fields that need automatization. And the future of the farming will less works and more decision and supervision, and to invite tools, robots to make an action in the field.
Mm-hmm.
And I think that iSprint is in the middle of those future farming.
In fact, I wonder, listening to what you said, Christophe, whether we have really found all of the stakeholders in this kind of environment. For example, stakeholders who are not just like the wine growers and the users, the consumers who are concerned about pesticides and things like that, but those who have to deal with the effects of climate change, including natural disasters. And you really struck a chord when you talked about insurance companies who have to deal with this all the time. Could you go back to that and tell us something about this and how even like maybe regulatory agencies would want to be able to access this information to help understand the effects of natural events that happen to you?
So yes, as we presenting the products during the iSprint and the farming solution during the show and other events, some companies, insurance companies, highlight a problem they have by covering the disease in the field. Actually, they're covering a standard amount on the field linked to a declaration, a global declaration of damage. And everybody's, farmers and insurers, expecting solution who can estimate by the more precise way what is the real damage linked to the real events. And by with iSprint and the yield estimation, we can check each time the material goes through the rows, through the vineyard, we can estimate the future yield. So between two scanning of the vineyard, we can detect an evolution, and maybe this evolution can be linked to an event, a climate event, and then we can imagine to have an agreement between the farmer and the insurer to pay the right amount linked to the damage. And it can be an important solution to decrease also the pressure on the farmer linked to the payment of this annual insurance.
Can you think of any other stakeholders that might be interested in this kind of thing? I would imagine that even government agencies might be interested in having the kind of data that you're able to collect now in order to make predictions and things like that.
It can be imagined, and it can be imagined if there is a global acceptation of those tools. It means that if this tool is only used by one person in one area, it can be interesting. It's the important fact in these projects. It's that the information have to be shared. It means that a vine grower with his neighborhood, who are also vine grower, if they don't share information, the system won't be precise, really enough precise.
Okay, understood. So I'd like to go back to Enrico and ask you once again, Enrico, what was the toughest challenge you did face and what you think really needs to be addressed going forward, because it is not really completely resolved yet and needs more study?
I think we have some homework in terms of wiring the box with the tractor. So the first test was actually better than we expected, but I think we can improve there, especially if the tractor changes speed very quickly. So I don't think we are able to cope with that well. So we will need more testing. So that's something that we will need to work more on that. There are some very practical problems. For example, we would like to do a disease detection with the images, but we don't have enough material with diseases, so we cannot train a model because we don't. And of course, farmers don't want disease, so they will not spread diseases only for us, so that we can take pictures. Also the what Christophe mentioned, that this yield detection, that's something that would be really, really interesting. And it's something that we will start. And we can start with those images, but I think it's also tricky, it's challenging. So it will take a few seasons before we have a model that is reliable. Looking back at what we did, yeah, now that we solved all the issues, everything looks very simple. But I think at the time, maybe with Oscar, so at the beginning we were very so our first performance test was miserable, so it took 3 seconds to process one image, and the improvement took some time, but at the end was very successful. So also the colleagues in Valencia were really, really helpful on this.
Now, in the other use cases of AI Sprint, the medicals and wind turbine, in both of those, there were problems of privacy or people not wanting to share information. Now, you just mentioned how farmers don't like disease, so they don't like to talk about it very much. I think it's a question in this area too, whether there are these kinds of problems.
Yeah. So I think
go ahead.
So I would say the Barcelona use case, or the health use case, is really critical in terms of data privacy, because that's
absolutely
as critical as it could be. The maintenance use case is probably has the same challenges. So the customer, of course, want to keep their images for themselves, not to share with others. Yeah, at the end, so data is the new oil, and you don't want to give out your oil for free. You want to sell it. But maybe Christophe can comment on that.
Yes, imagine the new oil, but also I think that the thinking, or the way of thinking are also changing, and I think that a lot of people, of farmers, or start thinking that sharing also information, and if we can confirm and improve that this information are safe, maybe they accept to share those data. And I think that an important aspect of the farm world was the exchange of information. Farmers, when they were together, they are exchanging information, discussing. So exchanging data are not so won't be a problem. It's only the way of convince them that those data are safe and protect.
This is Gustavo. I was going to ask you what you think about this. You're all about community building. So
yes. And actually, I feel very much the concept that Christophe and Enrico were saying about the privacy, about sharing information. I have been working with farmers for 10 years, and out of all the different businesses that I have been involved in, probably the farming is the most jealous business about information. Farmers are really keen in keeping their information, right? Christophe is smiling about it, and they're very diffidenti. I don't know how you say it in English. Diffident. Okay, thank you. So exactly. They are really tight and rigid about sharing information. But as Christophe said, explaining them which is their own interest in sharing this information, as how much this can benefit their own farms, it's important to involve them. And then it's very easy to prove the positive outcome of sharing information because of better farming practices. This is really, really important in the farming market.
The illustration of what you say is, for example, the climate detection. actually a lot of farmers have their own station for hygrometry, for cloudy, and so, and they will have a more precise information if they share information with other farmers who have those kind of station. That's why if they are convinced that there is a benefits for them and that the information are safe and not sold by other company, I think it's a good.
Yeah, Davide, this is about much of AI Sprint is about privacy preserving sharing, and I'm sure that that something can be done here. But you, in your AI work, of course, you have this tension between sharing and privacy preserving. What is the research community doing to try to help here? What can be done with this problem of sharing all that data that needs to be there?
Unfortunately, sharing data is not my field of research, so I'm not expert in this field.
Yes. Okay. Enrico, do you have any comments on how you can help out with this whole problem of privacy preserving and yet building a sharing community also?
Yeah, I wish I had an answer, and if I had one, probably I would keep it for myself and make money out of it. So I think what Christophe said is pretty it's really the point. So if you can convince your community that they are putting their data, they are getting something out of it, but they can control how their data is being used, you pretty can build this sort of trust. But I think it's really a challenge. In this AI Sprint project, we have some tools that help to, in a sense, to hide data. So you could like all the federated learning research that the Politecnico is doing goes into that direction. So can you help others to build models without giving your data to them? But this is kind of like a different approach. It's not about building a community. It's more like making others use my data without giving it to them. But it's a very interesting topic, which I really have no answer.
Gustavo.
I do believe that this privacy issue is a generational problematic. Today, the stakeholders and decision makers, especially in the farming, are rather how to put it in words, not offensive, old generation sort of way. And the new generations are much more open to share information because new generations now in university where Davide is working, with Danilo is working, in the universities is the good way to sensibilizing people that sharing information is adding value. Because as of today, what adds value when someone is a professional is the decision making, not the holding of information. So the more we share information, the intelligence of the person and of the professional is how to apply that information for a better use.
Mm-hmm. That very convincing. That would be your pitch to the farmers with whom you've been dealing over the years. Very good. Christophe, would you like to add your impressions to that? Do you believe that there's a new generation that needs to be created of farmers who believe in sharing?
I fully agree. It's clear more and more farmers are working together to find solutions. During this project, we have to find vine grower. We have to ask them if we can go in their field for teaching the project. Mm. And the question appears. They ask, but what about the data? And I try to explain that it's not a way of rob your data, but it was the way of having more and more precise system who can offer just the decision. And it's important to focus on they are managing their field with more and more precise elements linked to the volume and the quantity of data. And it's more important for them than the privacy of those data, I think. Have more precision.
I think that is a great way to close this panel. If anybody else has any remarks they would like to say, by all means. Otherwise, I would like to thank you for this fascinating discussion. I see that we have now a real challenge ahead of us, not only technical, but also to unite the farming community in a feeling of common purpose. And it's good to know that AI Sprint can make a good contribution to that. So first of all, thank you very much to all of you for participating in the panel. I would now like to begin to close our session with, hopefully, I am sharing. Oops, am I sharing indeed my? No, I don't think I am. I think I'm sharing the wrong screen. Hold on.
Correct, John.
Oh, okay. Sorry. Then I'll do it again. Okay. Sorry. Okay. So once again, thank you so much to our panelists and to the participants. Thank you for participating. And I would like to point out to you, to remind you that AI Sprint is going to have its final event just next month, not long from now. It will be in Milan and also online. And it will present not only this, but all of the results of AI Sprint together with other special events happening around it. So I hope that as many of you as possible will participate in this event. And so please go online now on the AI Sprint website and take a look at it and sign up. And we'll be looking forward to see you in Milan. And maybe we'll bring some wine to give to you while you're there. So once again, thanks to all. It has been a pleasure. Please keep in touch with AI Sprint, and hope to see you again soon, perhaps in Milan. Thank you.
Thanks to you.
Thank you very much.
Bye, everybody.
Thanks to everybody. Very interesting discussion.
Thanks to all of you. Bye.
Bye-bye.